All right, welcome back. It's time. I would like to remind you that our homeworks are typically due on Wednesdays. So next Wednesday is going to be our first homework assignment. And if you go to our class website, you will see the homework assignment there waiting for you to do. So usually I will post it like sometime after class on Friday, just because I'm always not quite sure exactly how far we'll get on Fridays. I tried to guess this time, so hopefully we'll make it through all the stuff that I put on the homework. If not, I'll change the assignment later on. But check it out. It's due on Wednesday. Remember, you're going to send it in through GradeScope. Please let me know if you have questions or you don't know where to see it or something like that. All right. Sorry, it's kind of cold in here. I don't know why. I'm cold. Let's continue talking about voting. So last time we were talking about this real-world example of this was the Florida election for the president in the year 2000. Like I said, all of the other states were kind of equalized in terms of the electoral college, and so, but the votes were super close in Florida, and so it came down to whoever wins Florida was going to become the president. And this was the final tally of votes in the state of Florida. This went through several rounds of recounting, and there was a lot of controversy when they were counting the ballots. I don't know if you ever saw any of this sort of ridiculous stuff about, in Florida at this time, they were doing their elections on punched cards. So the way it worked was you get like a piece of paper, which is your ballot, and rather than filling in like Scantron style bubbles, that's how we do it in Connecticut now, rather than that, you actually took a little like a little poker, and you poked it through the ballot where you wanted to vote. It had little like perforated rectangles, and you're supposed to poke out the one that you wanted to vote for. And there were all kinds of ridiculous things while they were counting the votes. There were some ballots. So when this is the absurdity that happened. When you poke the thing out, it was a little rectangle. You poke it out, and that little rectangle of paper is supposed to like fall on the floor. That little thing is called a chad. I don't know why they called it that. That's a chad, all right? And there was major controversy about ballots with a hanging chad. And I don't remember, it was either the Democrats or the Republicans said, if you poked it, but the chad was still attached, like on one corner, and it was like hanging there, they said that doesn't count. Because somehow they realized that the number of hanging chads was actually greater than the difference between Bush and Gore. And so it was eventually determined that the hanging chad should count. That if the chad was hanging, then it still counts. But then they said, okay, what about the dimpled chad or the pregnant chad, which is when the top and the bottom were still attached, but the middle was like poked out. Like you can tell somebody tried to push it out, but they didn't actually push it out. That was called a dimpled or a pregnant chad. I believe those were not counted in the final result. But these silly things actually made a big difference. And a lot of people were upset after this election because this final number that I wrote here was officially decided by the Supreme Court. And there was a lawsuit. It was called Bush v. Gore. Bush sort of sued the Gore campaign. And the lawsuit prevented them from recounting the votes again. And this lawsuit immediately was decided by the Supreme Court, and the Supreme Court decided, no, they should not count the votes again. Those numbers that I wrote down, those are the real numbers. That was decided by the Supreme Court, which is kind of very suspicious in the mind of legal scholars. You know, the Supreme Court is supposed to be politically neutral, and they're not supposed to get involved in politics. This was, you can't really get much more political than basically the Supreme Court decided who the president would be. And the votes on the Supreme Court were strictly by party lines. It was like it was a 4-3 decision, and the 4 people who voted for those numbers were the ones who had been appointed by Republicans, which is Bush's party, and the 3 people who voted against were the ones who were appointed by Democrats. So it was regardless of how you feel about the outcome of the election, this is not really how American democracy was meant to work. Although, I mean, if there's basically a tie in the numbers, what else are you going to do? You have to somehow decide, somehow. There were no good solutions. But anyway, very, very strange and controversial time. I think Spike Lee made a movie about this. Anybody know? Is that true? No. I think there was a documentary, I think, called "We Was Robbed," about how basically whoever made the documentary, I think it was Spike Lee, thought that Gore should have won. But anyway, it was a long time ago. Although it was important, you know, Bush, a year later was when the 9/11 attack happened, and I think it's fair to say that Gore would have reacted differently than Bush did. It made a big difference that Bush was president then. Okay, anyway, as I said at the end last time, though, if you asked, what I want to focus on is Naders' involvement here, right? Nader, like I said last time, was sort of the super liberal candidate. Bush, you could say Bush is a conservative and Gore is the liberal. Nader was the super liberal. And it's fair to say if the voters had ranked their choices, it would have looked something like this. And this, I think, is what I wrote at the end last time. You have basically 2.9 million people. The people who liked Bush the best, if they had made a ranking, they probably would have said Bush and then Gore and then Nader. That is, they like Nader the worst because he's the outsider, sort of extra liberal candidate. If you had asked the Gore voters to rank their choices, actually this is not really clear. The Gore voters, Gore being sort of in the middle of these three guys, it's not really clear who their second choice would have been. But I'm going to be as charitable as possible to Bush here, and I'm going to say, let's assume that those Gore voters would have put Bush in their second place. This is probably not true. Probably a lot of them would have liked Nader better than Bush, but I'm gonna give the benefit of the doubt to Bush. And then we had that 97, which I'm gonna sort of round to 0.1 million. 0.1 million would be 100,000. So, and these are the Nader voters, and it's fair to assume that the Nader voters would have ranked the candidates in that order: Nader, then Gore, then Bush, because Nader is the outsider, the liberal. They would have liked Gore better than Bush. All right. Now, I mentioned last time the system in which you just count the first place votes, there's a name for that. That's called the Plurality System. So using the Plurality System, that's the one where you only consider the first position votes. Now, in the chart that I wrote here, it's basically a tie between Bush and Gore because I rounded the numbers. But as we all know, in reality, using the Plurality System, Bush wins. That is narrowly, right? It was basically numerically a tie, but they got to do something, and the final count made Bush the winner. But I would like to look at the pairs. This is something we did in one of our made-up examples last time, but I want to look in this example, what if we look at the pairs? That is to say, I compare only, imagining it was only between Bush and Gore, who would have won in that case? Or what if I imagine it was only between Bush and Nader, or Gore and Nader? So I'm going to compare the pairs. Oh, sorry. Look at the pairs. If I do, so there's three ways to pair them up. I could do Bush versus Gore, I could do Bush versus Nader, or I could do Gore versus Nader, right? Those are the three ways that you could just choose two of them. And what if we compare the votes in each of those three scenarios? So for Bush versus Gore, I'm going to look up here, ignoring the Naders, add up the votes which have Bush above Gore, and then also the votes which have Gore above Bush. So in this case, I would say Bush gets this first column, they like Bush better, and the other two columns like Gore better, if it's just between Bush and Gore, right? So if it was just Bush versus Gore, Bush would get 2.9 million. I'll just write everything in terms of millions, and then Gore would get, the second column has Gore above Bush, and the last column, so I'm going to add those together. 2.9 and then plus 0.1 would be 3 million, right? And in this case, Gore would be the winner, right? If it were just between the two of them. This is why all the Democrats, at least, were mad at Nader. They said, bro, if you had just dropped out of the race, then Gore would have won, which is what we all wanted anyway. Nader kind of ruined it for Gore. The Republicans were pleased with this outcome. Anyway, what if we had done instead Bush versus Nader? Maybe really Nader was going to win anyway. No, he wasn't. But what if we had done Bush versus Nader? Then I go Bush, and I go Nader. I look at the columns again. Who has Bush above Nader? That would be the first column and the second column. That's 2.9 plus 2.9, that many, which is 5.8, I happen to know. All right. By the way, this is the level at which I would expect you to be able to do things without a calculator on our tests. It's not going to be much more complicated than this kind of thing, what I'm doing right now, which I hope you feel comfortable with. And then Nader, how many people actually put Nader above Bush? Only the last column, so that's 0.1. All right, so in this case, Bush wins. If it were only between Bush and Nader, this is not a surprise. Nader was the outsider. Bush at least was like one of the ordinary candidates. And then what about Gore versus Nader? A similar thing will happen here. So Gore, who has Gore above Nader? That's these ones and these ones. So that would be, again, 2.9 plus 2.9, which is 5.8. And then the Naders is the last column only. That's 0.1. So here, Gore wins. All right. So in no scenario would Nader have won, right? Nader was the outsider candidate. Everybody kind of knew that Nader was not going to win. What's interesting about this, though, is if Nader had not been around, then Gore would have won, all right? One thing I want to notice special about this, if I were to like circle the winners each time, I had Gore, then Bush, and then Gore. Now, Gore is not the winner every time here, but that's only because like there is no Gore in the middle one, right? Actually, Gore is the winner, so I want to notice the G is the winner in any pairwise contest. Of course, involving G, right? In any head-to-head competition, Gore would have won. Now, you might say, well, what about this one where Bush won? Well, that I'm not really counting that because Gore wasn't even part of that. But in any head-to-head competition in which Gore was participating, Gore would have been the winner. This is really a very kind of a strong statement about the fact that people liked Gore better than the other two, like Gore better than Nader or Bush, because if it were one-on-one between any of them, Gore would always be the winner. All right. There's a name for this. This is called. There's a name for that. It's called a Condorcet winner. Remember this name, Condorcet? It was about the Condorcet paradox I mentioned last time. That was about the fact that, like, sometimes when you ask people about their individual, when you compare things in pairs, it doesn't always make sense in the end. The results of everybody compared in pairs. But actually, this is an example where when you look at the pairs, it actually seems very clear that Gore is preferred, right? In any pairwise matchup, Gore is preferred. So anyway, there's a name for this. I'm going to write this as a definition here. You know, mathematicians like definitions. A candidate, sorry, who a candidate who would win in any pairwise matchup is called a Condorcet winner. All right. Now, the word winner here doesn't mean that they won the election. Like, Gore did not win the election. So he was not the actual winner in the real world. But this sort of mathematical term, Condorcet winner, it means somebody who would have been the winner in any one-on-one matchup. So you could say the reason Gore did not win the election is because of Nader. It's because it wasn't just a one-on-one. It's because somebody else was involved. And actually, there were other outsider candidates who mattered in the Florida election. Also, there was a guy named Pat Buchanan, who was sort of an ultra-conservative, who also messed with the vote totals a little bit, but not as much as Nader. All right. A candidate who would win in any pairwise matchup is called a Condorcet winner. So in the Florida 2000 election, Gore was a Condorcet winner. But, as we all know, did not win the election. All right, this can happen in the real world. I thought, just for fun, let's talk about a little theorem. Can you believe it? Theorem is the mathematical word for like a true fact that I can prove. All right, now we're not actually going to do a lot of theorems and proving of theorems in this class, but every so often we will. And it's nice to be able to think in a specific way about this. So the theorem says, in an election, there cannot be two different Condorcet winners. All right. There cannot be two different winners. I left out the important word. Two different Condorcet winners. Obviously, in the real world, you have one winner, but this concept, Condorcet winner, two different Condorcet winners, all right? Remember what a Condorcet winner means? It means somebody who would have won in every head-to-head matchup. Anybody feel like this is true? It's not possible to have more than one person who would have won in every head-to-head matchup. Can anybody say maybe a few words about why you should believe that? I know it's cold in here. Any ideas? Yeah.
Well, when they face up, one of them has to win.
Yeah, right. If you let's just imagine. What if you had two different people, and both of them would win in every head-to-head matchup that they ever had? Well, at some point, those two people are going to have to match up with each other, and then only one of them can win. So that scenario that I said is not actually possible. That two people both are going to win every head-to-head matchup. That's what I'm going to say. So I'm going to try and write something like that. I'll write it like a proof, right? This actually, I don't know if you feel weird about writing mathematical proofs that use basically no numbers or equations or anything. Everything I'm going to write here are words. But actually, this is the way that most real-world mathematics is typically written, in words. All right? Anyway, actually, what he just described or sort of outlined for us, that basic idea, is what we call proof by contradiction. You imagine, okay, what if there really were two such people? And then you show that somehow that's actually impossible in the end. So I'm going to say, imagine there were two Condorcet winners. Let's call them A and B, just for fun. And what he said was, at some point they have to match up with each other. All right. So imagine there were two Condorcet winners, say A and B. Then there will be a pairwise contest, A versus B. And it's not possible for them both to win there. And that's really what makes this whole scenario impossible. So both A and B. Can I move the word both? I think it sounds better to say A and B cannot both win, right? I'll say it both times. Both A and B cannot both win. So one of them actually isn't a Condorcet winner. Because the Condorcet winner means you win every time, right? So it's impossible to have two different Condorcet winners. The end. All right? This is my little proof. This is called a proof by contradiction, where you imagine that the thing you're saying was not true, and then you show that actually that's impossible. So it must be true. All right, wasn't that fun? I thought every so often we will talk about things like that. I don't think this is a very hard idea. This is the level of, this might be a question I could ask you about on a test or something. Explain to me why there can't be two different Condorcet winners. I hope that you would write something like this. You don't have to write like super formalized language or whatever. Just explain it in ordinary words. All right? Any thoughts about that? You can't have two different Condorcet winners. All right. So what we have is, you can choose the winner by doing the plurality system. But you could also look for the Condorcet winner, and sometimes you'll get different answers. Like in this case, Bush is the winner with the plurality system, but Gore was the Condorcet winner. So this suggests another totally different sort of system for choosing the answer. So a new voting method, this has a name, it's called the Condorcet Method, or Condorcet's Method. Rather than just looking at the first place votes, like in the plurality system, you look carefully at all the pairs and you figure out who the Condorcet winner is, and then you make that person the winner instead of the plurality. All right, this is called Condorcet's method. So how you do it, it's a lot harder than deciding the plurality, but you compare all candidates pairwise to find the Condorcet winner. And then they win the election. All right. This is called Condorcet's method. It's more sophisticated, maybe. I mean, at least it's harder to do. If I show you an example and ask you to find the Condorcet method winner, it'll take you a few minutes to do that. It's not really hard, but it takes a little bit more work. So I could say in this Florida 2000 election, Bush wins with plurality, right? That's what really happened in the real world, because in the United States we use plurality. But the Gore wins with the Condorcet method, right? Because he was the Condorcet winner. All right. I thought maybe we'd try another example. Let's try that big example from the handout that I gave you on the first day. So this was our 37 voters example. It was just, if you have the paper, that's fine, but I'll write the totals anyway. 14 people said A, B, C, D. 10 people said C, B, D, A. 8 people said D, C, B, A. 4 people said B, D, C, A. And 1 person said C, D, B, A. All right? There are 37 total voters in this example. I would like to find the winner using the Condorcet method. So remember, A was the winner with plurality. That's easy to tell. That's the one where you only look at the top position, and you can see A has 14 votes in the top position, which is more than anybody else. So A was the plurality winner. But let's find the winner using the Condorcet method. Find the winner with the Condorcet method. What I have to do is do all possible comparisons pairwise, and then see who is going to win all of their pairwise comparisons. So there's actually kind of a lot of them. I'm going to try and write down all the ways you could pair them up. First of all, you could go A versus B, A versus C, A versus D. Just to make sure I get them all, I'm going to try to write them in kind of like alphabetical order. Those are all the pairs which involve A. Next, the pairs which involve B. Now, I already wrote one of them, so I'm going to say B versus C, B versus D, right? And then I got one more that would be C and D. Those are the only ones. I hope I can fit all this on the screen. C versus D, right? And now for each of these, you got to look at the chart up top carefully. Sorry, I can fit it. You got to look at the chart up top and figure out what the totals would be. So between A and B, how many people put A above B versus how many people put B above A? And you got to do a little bit of sort of counting and adding here. A above B would be the first column, and actually nobody else, because all the other ones have A at the bottom, right? So the ones who put A up top is 14, and the ones who put B up top is everybody else, which since there's 37 voters total, everybody else must be 23. They put B above A, right? And I'm just going to have to do that for each of these ones. Actually, the other ones for A are all the same, aren't they? Because A is always on the top for 14 and below everybody else. And so A versus C will be the same thing. And A versus D, again, will be the same thing. 14 people like A better, and everybody else likes D better. The other ones are a little more interesting. Maybe could I ask you guys to try this out? I'm going to walk around. I hope you don't mind. I'm going to try and do this most days probably. Ask you to do something. I'll walk around and see how you're doing. I'm not trying to grade you or anything, but if you're not quite certain what's going on, let me know, and I would be happy to help out. Let's take a few minutes, see if you can do those other 3 matchups here. And I'm going to circle the winner every time. Here we had B, C, and D were the winners, right? See if you can figure out the other ones. And then remember, your ultimate goal is to find one candidate who wins in every possible matchup that they were part of. That's the Condorcet winning candidate. Doing all right? You know what you're looking for? Yeah. Okay. Your 2 numbers in each row, like if you write them like I did, it should always add up to 37 because that's the total number of voters. You doing all right? You know what you're looking for? Good? You guys doing okay? Still doing okay? Okay. All right, let's go over these. I don't know if you're finished. You got to look kind of carefully here. Let's see if we can make this happen. So B versus C, these guys, you're going to look in each column, and you want to count up how many times is B above C versus how many times is C above B. So how many times is B on top? Over in the first column, B is above, so there's 14 people who like B better than C here. Here C is above, here C is above. Here B is above C also, so there's 4 people over there. And then here C is above again. So the number of people who like B better than C would be these 14. plus these 4. That's a total of 18 people who like B better than C. So I'm going to put 18 right there. All right. And then who likes C better? Now, you could just say, since there's 39 people total, that means, I guess, that 19 people must like C better. 37 if I want these numbers to add up to 37. But you should be able to count them also. Are there really 19 voters here who like C better than B? There's 10 here, plus 8 here, plus 1 more here. So that's 19, all right? This is how we do it. So this one, C was the winner, right? And let's just continue. B versus D. How many people like B more than D? That's 14, plus another 10. Not them, plus another 4, and not them. So 14 plus 10 plus 4 is 28, I believe. So this one, B is above D 28 times, leaving D with only 9 times. You can count those up, or just add them up to 39. And then, so in that comparison, B was the winner. And then C versus D. C gets those 14 and these 10 and this 1. So 14 and 10 and 1 is 25. And D gets the rest would be 12. So C is the winner here. All right. I hope that's what you got. Like I said, this will take you a few moments of careful counting, but I hope you don't feel like this is not really hard. It's just you gotta be careful about it. All right. Anyway, what's my conclusion? What I was looking for, remember, was a single candidate who would win in any of their pairwise matchups. Is there any such a candidate here? Yeah? C. I think if you look carefully here, you will see. You know, it's not that C wins every time here, because C is often not even part of these. But whenever you have a comparison with C, that is here, here, and here, C is always the winner in those comparisons with C. So here, C wins all their pairwise matchups. So that means C is the winner using Condorcet's method. Right? C is the winner using Condorcet's method. Remember, like on the very first day, we sort of looked at these numbers and said, you know, A is up top here more than anybody else, so maybe A should be the winner. But actually, everybody else hates A. And I said something like, well, if you don't think A is the winner, then what else are you going to do? Well, this is one other thing, one other what else you could do, right? It's called Condorcet's method to decide the election. All right. Any questions or thoughts about that? It's a little harder to do than the plurality system, but, you know, takes a few minutes rather than a few seconds. That's all right. There's one major downside to the Condorcet method, which is probably why you've never heard of it, and it's actually, I'll tell you, the Condorcet method is not used in real-world politics anywhere that I'm aware of. Why is that? Anybody have an idea? Why don't we do it this way? And the answer is not because it's too complicated. It is kind of complicated, but actually that's not the reason why we don't, why nobody does this in the real world. Let's do another example here. How about, this is another made-up example. Let's say 12 people say A, B, C, 8 people say B, C, A, 7 people say C, A, B, and 2 people say B, A, C. This I added those up. There's 29 voters here. All right, let's just do the comparisons and see what happens if we use the Condorcet method. I suppose the plurality winner would be A in this case. A has 12 votes in first place. So A would be the winner if we use plurality. What if we do this Condorcet thing? So I need to compare A versus B, B versus C. I violated my sort of general alphabetical order. I'll do this way. A versus B, A versus C, and then B versus C. You only have to do 3 different comparisons here. Let's see, A versus B. I have 12 here who like A better. Also these 7, and that's it. So 12 and 7 would be 19 points for A. B would have to get 10 then. And so A is the winner if it was just between A and B. I hope everybody sees how I'm doing this by now. A versus C. Oops. A and C. All right, in the first column, they like A better. Here, they like C better, and in the last column, they like A better. So A is above C 14 times. That's the first column and the last column. And C is above A on the other two. That would be 15 times. So C is the winner here. I think I did that right. Feel free to interrupt if you think I messed it up. I often mess up the numbers. And then B versus C. All right, B is above in the first column and the second column and the last column. So that's 12 and 8 and 2. That's 22 for B. And C has the others, which is just the second column. What? No, just the third column, yeah, which is 7. All right, so in this case, B is the winner. All right, what are your thoughts then? Who is the Condorcet winner? That would be somebody who wins in every possible matchup that they have. The answer is, I see some shaking of the heads. The answer is, there ain't no Condorcet winner in this example. All right, so in this case, there is no Condorcet winner because there is no candidate which would win in all of their pairwise matchups. All right, and this, my friends, is why we don't use the Condorcet method in the real world, because if you're using the Condorcet method, you basically, in this case, have to say it's a tie. Even though the votes are not really, it doesn't look like a tie. I mean, there's lots of different votes for different people. It turns out in the real world, the Condorcet method very often will just say there's no winner. And you don't want that for practical reasons. You don't want that to happen in a real world election. Whatever you're using, if you're doing this in the real world, whatever method you choose, better be something which always gives you an answer. So no Condorcet winner. So it is a fact, actually, and this, this is a made-up example that I made up, but this is not like a fluke. Actually, this happens very often. If you just randomly make up an example, it's likely that there's no Condorcet winner. So I'm going to say very often there is no Condorcet winner, and this is why nobody uses this method in the real world. Very often there is no Condorcet winner. All right, I'll put a little sort of frowny. It means that this is not actually a practical method to use in the real world, because it results in a situation kind of like a tie. You just have to say there is no winner, which is almost never satisfying in the real world. So we don't use it in the real world. All right, in the real world. Unfortunate. Any thoughts about that? We got 12 minutes remaining. I think that's enough time to talk about another voting method. Can you believe it? They just keep on coming. We have the plurality system is the easiest one to do. It's the one that we use in American politics for the most part. The Condorcet method, which is a little more complicated and also sometimes doesn't give you a winner, which is why we don't typically do that in the real world. Here's another one. This one actually you can use in the real world. Like it always gives you a winner. It makes sense. It's not that hard to do. Another voting method. It's called, this is also named after a person, the Borda count. Borda is the name of the person who came up with this, although this is an example where I think any one of us could have come up with this also. If I just asked you to sort of brainstorm different ways you could try to figure out who the winner is, probably any one of us would have eventually come up with the Borda count. It's not all that crazy of an idea. But here's the idea. After you do the vote, you have people list their rankings like we always have been. And then each ranking position gets points. And the way that it works in the Borda count is last place gets 0 points. Second to last gets 1 point, etc. The top position you get, well, it depends how many total people were involved in the election. If there were, well, let's just do an example. Anyway, you add up the points, and whoever got the most points wins. Add up the points, and the most points wins. This is called the Borda count. All right. You might wonder, is that going to be, are you just going to choose the same person as whoever the winner with the plurality is? Actually, it's not the same as the plurality. You can do the Borda and get different answers from the plurality. Anyway, let's try a simple example here. How about, here's another example. One person says A, B, C, D. One person says B, A, D, C. One person says C, D, B, A. All right? Let's try and find the winner using the Borda count. Using the plurality here, it's sort of a three-way tie, I guess. A, B, and C all got 1 vote in the first position. And so the plurality is a little unsatisfying in this example. Let's try and do this using the Borda count. I'm going to make another little column for my own reference about the points, right? Remember the rule I said, last place gets you 0 points, second to last is 1, and then up to 2 and 3. So the first place, when there are 4 candidates involved, first place gets you 3 points with the Borda. It's always 1 less than the total number of candidates. But anyway, let's just try to add them all up. So A gets, what you got to do, look at the various votes. I have 1 vote for A in the first position. That gets me 3 points. Plus, the middle column has 1 vote for A in the second position, which gets 2 points. Plus, the last column has 1 vote for A in the last position, which is 0 points. Add it up, you get 5, right? So A has 5 total points using the Borda. What else? Just do this again for B, C, and D, right? And again, this is not really hard. You just got to sort of look carefully and do it. So B has 2 points here, a 3 points here, a 1 point here. So I'm going to say 2 plus 3 plus 1. That's 6. C has 1 point here, 0, and a 3. So that's a 1 and a, I'm going to try to write them in order. 1 and a 0 and a 3, which is 4. And D has a 0, a 1, and a 2. 0 plus 1 plus 2. This is 3. All right, and so B is the winner using the Borda count. This is how you do the Borda count. Seems like a reasonable system, right? It's not that crazy. And you get a winner. In this example, like I said, if you tried to do just with plurality, you would get sort of a 3-way tie. But when you look at the Borda numbers, it tells you actually, even though it kind of looks like a tie to begin with, actually B is maybe a little bit better than A and C. And D is a little bit worse. All right? This is the Borda count. Let's just try another example. It can get, this was not so hard, I think. It can get, like, very slightly a little bit more confusing. Here's another one. When I have more than 1 voter in a column, which is like most examples will look like this, where there's more than 1 voter in each column. Again, I'll write the points over here, 0, 1, 2. This actually, the Borda count is the system which is used in Mario Kart. You into Mario Kart? After you finish the race, depending on which position you finish in, you get a certain number of points. And it basically works like this. Now, Nintendo is trying to help you out. Even I believe in Mario Kart, even when you score last, you still get 1 point, just as a little, here you go, kid, get your 1 point. And also in Mario Kart, there's sort of a bonus for coming in first. It doesn't go up by 1 every time. But anyway, the Mario Kart is basically like the Borda count. They also use something like this in the World Cup. I'm not into the World Cup, but I think it's like if you win a match, you get 3 points. If you lose, you get no points, and if there's a draw, you each get 1. Is that correct? Anybody know? Yeah. So, and then this is like in the preliminary rounds, and then they add up all the points to structure the final tournament at the end. But anyway, it's basically like a Borda system where you get points depending on positions. Can we add these up? So This is slightly more complicated because of these numbers up here. All right, what we have is A is getting 2 points from 3 different people. So actually, in this position, there's a total of 6 points for A. That's because 3 people put A in this position, and they're getting 2 points each. So I'm going to write this is 3 times 2 plus, I'm going to try and write it out in steps here. You could try and do all of this in your head, but it's a little confusing. Here, A is getting 0 points from 2 different people, so that's 2 times 0. Add this up, that would be 6 plus 0, which is 6. Can you handle that? You got to multiply here, unfortunately. What about B? B is getting 3 people gave them 1 point in the first column, so I'll say 3 times 1 plus, and in the second column, 2 people gave them 2 points. That's 2 times 2. This is 3 plus 4, which is 7. Remember, when you write things in this way, you gotta remember I'm writing using the ordinary order of operations, which is you should multiply first and then add. Okay, and then lastly, C is 3 people are giving them zeros, so that's 3 times 0, plus the second column, 2 people are giving them 1s, that's 2 times 1. And this is 0 plus 2, which is 2. So B is the winner with the Borda, all right? Exclamation. I have found, like, doing homework assignments for this topic, everybody likes to put an exclamation after the word wins. B wins. Yes. Go for it if you want to. You don't have to. All right? Maybe you've already been doing it. I'm into that. Let's try, how about the old Bush-Gore Nader thing? Let's see what would happen if we did the Borda in that election. So remember, I'm going to write this in terms of millions. 2.9 million say Gore, Bush, Nader. 2.9 million say Bush, Gore, Nader. And then 0.1 million said Nader, Gore, Bush. Remember, in all of this, when I write these rankings, I'm being generous to Bush by putting Bush in this position. Probably in reality, some of these people would not have put Bush in the middle position, but I'm trying to give Bush a break here. Bush doesn't need a break. He was the president twice. By the way, Bush's second election, you know, he was reelected in a much less close election. The second time around, there was no funny business with the Chads and all that, but also the totals of the elections was much clearer that Bush won, and people actually liked Bush better than the other guy. Anyway, let's do the Borda, right? So the way we do this is we're going to have to do the same kind of thing with multiplying and adding. So the points in this Borda election will go 0, 1, 2. And so in the first column, I have Bush in the second position, getting 1 point from 2.9 million. So this is going to be 2.9 times 1. When I write these multiplications, I'm always going to put sort of the number at the top of the column times the points that they got. So in the second column, Bush is up top. So this will be 2.9 times 2 points for the second column. And then in the last column, Bush is getting 0 points. 0.1 times 0. And if you add this up, I'm not into doing this kind of thing in my head, but I did this on my calculator ahead of time. I got 8.7 million Borda points for Bush. What about Gore? Gore is on top in the first column, so they get 2.9 times 2. 2 points from the first column. In the middle of the second column, they get 2.9 times 1 point from the second column. And then in the last column, they're in the middle, they get 1 point. So that's 0.1 times 1. And this is almost the same as Bush's total, but the only difference is here, right? Bush got nothing from the Nader people. Gore got a little something from the Nader people. So this adds up actually to 8.8 million. And so again, Gore is going to be ahead of Bush in the Borda. What about Nader? You think Nader's going to pull it out this time? No. Nader gets 0 from the first column, 0 from the second column. And Nader gets 2 points from the last column, so 0.1 times 2. That's 0.2. So as expected, Nader is not a contender. But Gore would have won if we used the Borda count. All right. This is how we do the Borda count. And I think that's it for us. Check out the homework assignment. See what you think. It'll be due on Wednesday. Please let me know if you have trouble finding it or doing the problems. I'm happy to help.